Thank you for attending our webinar today. My name is Scott Andrus, and I run the AppLabs service lines and global alliances. Our today is Rich Corbridge, and he will be discussing the topic of demystifying web application security. Rich is with AppLabs 2001 and currently operates out of our Linden, Utah facility. And recently, Rich was appointed head of AppLabs security service line in March 2009. And with that, I'll hand the presentation over to Rich.
Thank you, Scott. Good morning, everyone, or good day. Good day to you, wherever you are. Thank you for joining. Our topic today, as you can see, is demystifying web application security, what web application security is and is not. So my name's Rich again, and I've been involved with securing enterprise networks and systems for over 15 years. I've worked for banks and government and technology and startup companies. So I've had a little bit of relevant experience in this area, and I'm happy to be here today. Just as a basic definition, a web application is online software that we access via a web browser. And we've all used these kinds of applications. They range from mail applications to banking applications, shopping, social networking, project management, collaboration, etc. The examples and utility of these applications are almost endless. You can find an application for just about any need that you might have. Today we'll be talking about what makes online web applications secure. And how we can make or deliver secure web applications. When we think about security on the Internet, the first thing we think about is generally a firewall. A perfect firewall would protect our systems and networks by not letting any traffic in or out. But if we had that kind of firewall, we might as well just disconnect ourselves from the Internet because we couldn't share or receive any meaningful information. And so the drawback of a perfect firewall is that we cannot share information, and that's what we all like to do with our web applications. We have some information or a service that we'd like to provide, and so we need to come up with a more realistic way to operate. So, in order to share our information, we poke a hole in the firewall, or we allow certain web traffic through. For instance, HTTP or HTTPS that they can use to go to our web server and share information or gain access to our services. When we do that, we open up just the hole that allows web traffic through and nothing else. We call this principle least access. You only open the minimal amount of required access in order to protect your systems. And even though our firewall protects our networks and our systems by blocking everything but the web traffic, it doesn't block web traffic that could be bad or have malicious intent. So by itself, a firewall is not sufficient security for a web application. There's a question here. Aren't there firewalls that can look into the messages sent to the web server? The answer to that is yes. There are a variety of firewalls available, and some of them on the higher and more complex end can get deeper into the messages that are exchanged between a browser and a web server. These are very difficult to implement effectively. Creating the rule sets on them is very complicated, and because you'd have to categorize each message as being acceptable, or what kinds of messages and formats and content are acceptable for those. The sheer processing of every message against one of those is difficult. Likewise, in our web applications, we hope that if we have sensitive information that the transmissions or messages are encrypted, and as such, they would not be filterable based on the content. Which leads us to our next concept of encryption. When we think of security on the Internet, we also think of encryption. And this is the process of transforming information using an algorithm to make it unreadable to anyone except those possessing special knowledge. So let's look at a few examples of how that applies to our web application. If you and I wanted to share some information, and we didn't want our information to be read while it was in transit between you and me, we would agree in advance on an encryption algorithm or cipher. If we were 10 years old, we'd use a substitution cipher where the letter A is equal to K or the letter B is equal to L and so on. We would then follow the rules of our cipher or algorithm to transform messages and send them to each other. And while the message was between us, the bad guys or our little brothers couldn't read our messages. But because we both agreed on the cipher or algorithm, we can encode and decode each other's messages. If someone intercepts our messages in transit, we're counting on our cipher to protect the contents. A web application works in the same way. Only we're using browsers and servers to do the encryption and decryption on both ends of the communications link. So when I log into my banking application, I hope that my username and password are sent in an encrypted format to the web server. The bank and my browser, the bank server and my browser have negotiated the encryption, and so as we transfer information back and forth, we can encode and decode that information so that it's readable and presentable in our browser. While those messages are in transit between the browser and the server, of course, the messages are encrypted, and so anybody who happens to see the messages sees just the encrypted text. So let's take that a step further and look at the scenario where there's a bad guy, or somebody with bad intent, who uses the same bank as me, and he wants to do harm to the server or get access to information that he shouldn't have. There are messages that he can send from a browser through this encrypted connection to the server that will cause the server to do something harmful. And the only advantage of encryption in this scenario is that a second bad guy in the middle, bad guy number 2, won't be able to read the malicious content that the bad guy with the browser sent at the web server. The web server will still do its job with the content that it receives from the bad guy's browser after it decrypts the messages. So encryption by itself is also not sufficient to make a web application secure. A common component found in nearly every web application is authentication. Authentication is the process of establishing a user's identity or validating a user as who they claim to be. Authentication is usually implemented in the form of a username and password. Sometimes more secure implementations include two-factor authentication